Draw sheet number 1. Give the relationship between the following given structures as conformational isomers, constitutional isomers, enantiomers, diastereomers, cis-trans isomers, meso compounds are not related. Conformational isomers are compounds which have got the same molecular formula, same structural formula, but they've got a rotation about a certain compound, about a certain carbon. For example, number 3 here, you can see the carbon at the back for both compounds is having the same atoms. Carbon in front is also having the same atoms, but they have just having different rotation. So these are conformational isomers. Constitutional isomers are compounds which have got the same molecular formula, same structural formula, but different connectivities. For example, number 5, we have got 1, 2, 3, 4, 5 carbons. Here 1, 2, 3, 4, 5 carbons. But the only difference is that we have connected them differently. So those are constitutional isomers. Enantiomers are non-superimposable mirror images. Something is a mirror image of another thing, but if you get it and put it over the other one, they'll not be able to fit. For example, my left hand is an image of my right hand. But if I get one hand and put it on top of the other one, if they are all facing up, they'll not be able to fit. So those are enantiomers. And then diastereomers, they are also more the same, but the only thing is that for diastereomers, if one compound is having RR configuration, another one is going to have RS, or if one has got SS, another one is going to have RS. The only thing is that they are the same at all carbons, but the only difference is that they differ at one position. There is a rotation at one position. Those are diastereomers. Okay. For example, you can look at number 2. Hydrogen, hydrogen this side, chlorine, chlorine this side. But here we swap at only one position. We've just swapped one position. So these are not mirror images of each other. So we have just swapped at one position, and so these are stereomers. The rest have remained the same. I mean, they are diastereomers. And then if we consider cis-trans isomers, cis-trans isomers are simply compounds where one group is on top, one group is down, or both groups are on top, or both groups are down. And then meso compounds are more the same like enantiomers. So if I've got one compound where I've got RR configuration, another compound I've got SS configuration. That's those two are meso compounds. We have got a reverse of configuration at both positions. Now let's determine what we have here. Already we've discussed some, but let's discuss all of them. So if we consider the first one, already for us to be able to tell whether it is enantiomer, diastereomer, meso compound, we need to make sure that the compounds we're talking about are chiral. Now already if you see this carbon which is in front, this is a carbon in front, it is bonded to two methyls. Already it is not chiral because it has got two groups which are the same. Even this one, it has got two hydrogens, the carbon in front. So these definitely they are not chiral. So we can't think about enantiomer, diastereomer, and meso compound. Now, if you can see, all we have just done is we've gotten one methyl which is in front and swapped with with an hydrogen that is in the back, because the back carbon only had hydrogens. The front carbon had one hydrogen and two methyls. But you can now see that the front carbon has got one methyl and two hydrogens. So we have just swapped the way atoms have been connected. And about connectivity, constitutional isomers. Right. So number 1, these are constitutional isomers. 2, we already said conformational isomers. Number 5, we already said also constitutional isomers. Number 2, okay, this is number 3, the one I said 2. Number 2 here, this one, we already also said these are diastereomers. And then number 4, we can tell what number 4 is. So let's look at this carbon. All the atoms bonded, they are the same. They are different. Even here, they are different, meaning it does have chirality, each carbon. So considering this carbon, let's name whether it's going to be R or S. position number 1 will be given to the OH because O has got the highest molar mass. The next group, group number 2, will be this one. The next group will be this one, considering the molar mass of the carbon direct linked to this carbon. And then number 4 will be the hydrogen in the back. So you can see this one, the numbers are going in this direction. So what configuration is that? This is R configuration. If we consider again this carbon, group 1 will be chlorine. Chlorine has got the highest molar mass, followed by the nitrogen. And then this other group, this side, will be number 3. The CH3 is going to be number 4, which is still at the back. So this will still go in this direction. So the configuration is still R. If we consider this molecule, which is here. Now, one thing I did mention, this one, this structure at 3, we call this as sawhorse projections. And then these ones which are here, which have got circles, we call these as Newman projections. Okay. And then we do also have these ones where we are just using lines. So these lines, we call these as Fisher projections. Okay. So I've got sawhorse, Newman, and Fisher projections. Now let's consider this one here. How do you name the chirality? Now, one thing we need to know is that these groups which are always at the terminals, they are in the back. And then the groups which are on the sides, they are in front. And then, so this group, the chlorine, the hydrogen, the amine, the OH, these are in front. And then this line which connects these two, it is on the board or parallel to the board. So considering this carbon which is here, number 1 will be the chlorine, number 2 will be this one, number 3 will be this bigger group. So number 4 will be the methyl. So you can see we are going in this direction. What configuration is this? Already the fourth group is in the back. So what configuration is this? This is R configuration. Let's look at the other carbon. For the other carbon here, OH will receive position number 1. This bigger group will receive position number 2. Methyl will receive position number 3. So this was supposed to be going in this direction, which is the S configuration, but the fourth group is in front. So we're going to reverse configuration. So the configuration is going to be R. So you can see this is RR, this is RR. So number 4, this is just the same compound. Okay, this is the same compound. We've just converted it from sawhorse into a Okay, we have converted it from a sawhorse into a what? Into a Fisher projection, the same compound. And then if you consider the fourth compound, it's basically the same. All you have done is rotated it.